what an arc was and the different types of arcs. So today we're going to look specifically at inscribed angle. So an inscribed angle is an angle whose vertex is on the circle. So let's say we have a circle here. We have an angle, and that vertex is on the circle. Okay, and then this inscribed angle, it has two endpoints on the circle, right? So it has a vertex on the circle, its two endpoints are on the circle. The space between these two endpoints on the circle, that is called the intercepted arc. So it's the arc between the two endpoints of an angle or some sort of segment or line. Okay, we could draw a chord through here. Chord has two endpoints on the circle. Just a moment.
¿Ustedes saben quiénes son los zetas? ¿Ustedes saben quiénes son los zetas? ¿Los zetas saben quiénes son? Son un grupo donde ellos mataban gente o les participaban, ponían perfectamente a los zetas. Entonces están haciendo mames de eso, pero le cambian el nombre a veces a los zetas. Como mirando un gato tirado.
All right, sorry about the interruption. So it's the arc between the two endpoints of an angle or line or segment. So if we're looking at this circle over here, we have our inscribed angle in purple. Its intercepted arc is that red arc. So we're talking about like the crust of your pizza, right? That's your intercepted arc. Okay, so the other day we talked about central angles. And central angles, their angle measure was the same as its intercepted arc. Inscribed angles, they are not the same as their intercepted arc. Okay, So the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So therefore, we can say that the measure of angle ADB is equal to 1/2 the measure of its intercepted arc, and that arc is AB. So there's our angle. And there's our arc. So let's take a look at the inside of your notes here, where we have some examples. All of these on the front are just like our definitions, some information. Let's take a look inside at example 1. It says find the indicated measure. So we're asked to find the measure of angle T, and we're asked to find the measure of arc QR. So let's first talk about the measure of angle T. I'm going to go ahead and highlight angle T. Okay, so there's angle T. Its endpoints form what arc? RS, right? Okay. The endpoints of angle T, or RTS, form arc RS. What's the relationship between an inscribed angle, this is an inscribed angle because the vertex is on the circle, and the arc? What's the relationship? The angle is half the arc. So this angle is going to be half of what? Half of 48. This is 24. Okay? All right, let's talk about part B, the measure of arc QR. Okay, right there's QR. The endpoints of QR, is that formed by any angle that we're given? By any angle that we're given? No, it's not, right? But we are given another angle, correct? We're given this angle. If we know this angle, what is its intercepted arc? QT, TQ? And what would that measure be? Not 50, 100, right? Because we doubled the angle to get the arc. Well, what's segment TR called? A diameter. And what's true about a diameter of a circle? It's half the circle. So a diameter forms what's called a semicircle, right? And a semicircle is how many degrees? 180. So that means QR must be what, so that we have our total of 180? Has to be 80. Okay. So any questions on the basics of inscribed angles? Okay. Back to the front, let's talk about this inscribed angles of a circle theorem. Okay, this states that if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So we have two angles here that are marked congruent. We have angle D. Let's take a look at angle D. Its endpoints form what arc? AB. Let's take a look at angle C. Its endpoints form what arc? AB, right? So since angle D and angle C, their endpoints are on the same arc, that means that those two angles must be congruent. Does that make sense? Okay. So let's take a look at example 2. Find the measure of arc RS. Here's arc RS. If you notice, it's the endpoint of two different angles, right? Arc RS has the endpoints of angle U. So if angle U is 31, then what is arc RS? 62. Okay. But arc RS, its endpoints also form what angle? Angle T. So what's true about angle T? It's congruent to U, so angle T has to be 31. Okay? So we can say that angle STR is congruent to angle RUS because they intercept the same arc. Okay, let's go over here to example 3. Find the measure of angle GFH. GFH. Well, there's nothing there. Its endpoints form what arc? Its endpoints form what arc? FH, that's formed by a vertex and an endpoint. We want the two endpoints are formed GH. Do we know anything about arc GH? It shares endpoints with what angle? Angle E, right? So if angle GEH shares the same endpoints as angle GFH. What's true about angle GFH? It's also equal to 75 degrees. Good. Example B, find the measure of angle HGF. Look at its endpoints. Where are its endpoints? Arc HF. So then how do we find angle HGF? What's that? Not going to times it by 2. We're going to divide it by 2. Good. Take half of 90. So that would be 45. Okay, example C. We are looking for arc TV. Well, TV, it's the endpoints for angle TUV. So how can we find arc TV? 2 times 38, good. Just 76, good. Part D, we're looking for angle WXZ. So W to X to Z. We don't know anything about its angle. We currently don't know anything about its intercepted arc. But what do we know about that arc? It has the same endpoints for angle ZYW, okay? So if they have the same endpoints, what's true about those two angles? They're equal, good. So we're kind of getting the hang of inscribed angles and then their intercepted arcs. So let's talk about some inscribed polygons. So back to the front. An inscribed polygon just means that the endpoints, the vertices of a polygon, they are all on that circle. Okay? So we're specifically going to talk about inscribed right triangles. We'll tell you why it's a right triangle in a moment. And then inscribed quadrilaterals. Quadrilateral meaning 4 sides. The inscribed right triangle theorem. If we take a look here, this is a right triangle. Where do you think that right angle is? At which letter do you think the right angle is? B. Okay? Let's take a look at that angle B. Where are the endpoints? AC, right? What's true about AC? It equals 180. Why does it equal 180? It's a semicircle. AC also forms a what's AC? The segment I just highlighted. The diameter, okay? So that's what gives us what's called the inscribed right triangle theorem. So basically it's saying that the measure of angle ABC is equal to 90 degrees if and only if segment AC is a diameter. Because we said that this red arc is 180 degrees, what's half of 180? 90, okay? And then we have what's called the inscribed quadrilateral theorem. Okay? Inscribed quadrilateral theorem states that opposite angles are supplementary. What does supplementary mean? Equal 180. So what is one pair of opposite angles here? E and G. So we can say the measure of angle E plus the measure of angle G equals 180. What's another pair of opposite angles? F and D. The measure of angle D plus the measure of angle F, that is also equal to 180. All right, let's go back inside and finish these final 4 examples. Part A. Find the value of each variable. Find the value of 2x. Well, what's true about that angle of 2x? What do you notice about the endpoints of the angle? You have your semicircle. It's your 180. So, what's true then about the angle? What's that? It's a right angle, yes. So that means that 2x has to equal 90. Therefore, what is x? 45. Part B. This is called an inscribed quadrilateral. We have 4 sides. What's true about inscribed quadrilaterals? What's 180? Opposite angles. Good. So what is one pair of opposite angles? Did you say G and E? G and E. So that means that y plus 120 equals 180. Opposite angles are supplementary. So what is y? 60. Our other pair of angles are what? D and F. So z plus 80 is equal to 180. So what is angle Z? 100. Okay, example C. Let's first find angle X. Well, what do you notice about angle X? Where is its endpoints? MK, right? What does that form? Semicircle. So what's true about X? The arc is 180, yes. But what's true then about X? It's 90. How can we get Y?
90 plus 40 plus y.
Okay, so Y plus 90 plus 40, you said equals 180? Good. We know the 3 angles in a triangle equal 180. What's 90 plus 40? 130. So what is Y?
50.
What's up? This is a triangle. Oh, triangle is a polygon. This next one's a quadrilateral. Yeah, part D is a quadrilateral. So because we're looking at a quadrilateral, we want to look at what? What do we know about quadrilaterals? Opposite angles are supplementary. So what is a pair of pair of opposite angles here? U and S. Okay. So U and S, that means we have C plus 2C minus 6 is equal to 180. Well, what's C plus 2C? 3C. Add your 6. Equals 186, and then divide by 3 and you get 62. Okay, what's our other pair? Okay, T and V are the opposites, so we have 8x plus 10x equals 180. So 18x equals 180, so what's x?
X equals
10. Good. Questions? Okay, so your homework for tonight is to complete homework 10.4A. 10.4A.